hopefully you've gotten a chance to think through the Starburst problem a little bit. If you haven't, I'd really encourage you to spend some time with it and just think about what's the probability of getting a red Starburst. So you open a pack of 2, you have no idea what's in there, you just open it. What's the chance of getting a red Starburst? Could be just a single red, could be a double pack of red, but what's the probability? Well, there's a number of ways students usually approach this. I'm going to share some common answers I've seen in the past that are wrong answers. Okay, some people say 1/4. They just say, hey, there's 4 colors, one of them is red, so it must be, the probability must be 1/4. Seems reasonable, good thinking. The issue is there's 2 Starbursts, right? What happens if you don't get, like, it's okay if they're not both red. What if, doesn't getting 2 give you a better chance? Like if you were only going to get 1, it seems like it would be 1/4, and it would be. But since you're getting 2, it seems like we should have a better chance. So some people kind of take that and run with it. Say, well, 1/4 plus 1/4 is 1/2. You got a fourth of a chance of getting a red on if you had just 1, but since you're getting 2, then let's just add them together and let's get 1/2. And that's actually a lot closer to the correct answer, but it's not theoretical. It's not the theoretical probability. Okay, and we'll take a look at why here in a little bit. Some people suggest taking, well, let's take 1/4 times 1/4. It seems like if addition doesn't work, multiplication might. Problem is that gives us 1/16, which is really small, way less than 1/4. And it seems like, I mean, the probability of getting a red shouldn't be less if we're getting 2. It should be more than 1/4. Okay? Usually there's a student or two who thinks about it this way. And if we think about listing out the possibilities, this is the sample set. We could have a red and a pink. We could have a red and a yellow, a red and an orange, a red and a red. An orange and a pink, orange and a yellow, orange and an orange. I didn't write orange and red down. Students often say, well, I already have orange and red over here, right? Okay. And so they leave that off. And then they think, well, yellow and pink and pink, and then this would be pink and orange, but I already did pink and orange, and pink and red, but I already did pink and red, so I'm going to leave that one out. I feel like I switched those around in the way I was thinking about it. Let's do yellow, yellow, and then pink, pink. I'm thinking of these as the first starburst each time, and this as the second starburst. So I've already done all my reds first, then my oranges, now my yellows, and then pink, pink, but then all the rest of the pinks are already out here. Pink, yellow is here, pink, orange is here, pink, red is here. And so students that think like this say there's, how many is there? 4, 5, 6, 7, 8, 9, 10 possibilities. And of these 10, 1, 2, 3, 4 of them have a red in them. So the probability is 4 out of 10. And this is actually the closest answer, at least it's between 4/10 and 1/2. I'm not sure which is closer. It's halfway in between. So these two are the closest answers. Stop. Here we go. So these two are the closest. Probability 1/2 and 4/10. But none of these are correct. So let's take a look. If you want to pause this video, and now that I've kind of given you these wrong answers, if you want to think about it, it would be really helpful for you to think through the probability. Otherwise, you could just take a look at the rest of the video. My kids and I actually opened up 97 packs of Starburst. Maybe I shouldn't tell you this, but I had them ready to give you in class one day, and we were going to do this in class together. So I'm sorry. Feel free to go out and buy yourself a bag of Starburst to make up for it. But what we did is we opened up the 97 packs, and of them, 35 had a red. And so, thinking back to what we talked about with empirical probability, also known as experimental probability, thought I had that written down somewhere, but I'll just type it in my calculator. If we know 35 out of 97 had a red, we would say, we could just divide that. The probability is about 36% chance, or 35 out of 97. And that's actually a little bit lower than the actual theoretical probability. But I'd like to point something out. You'll notice we organize these in pink-yellow combinations. Now, I don't know, when you open a package, is it pink-yellow, and then if you flip it over, is it a yellow first and then a pink? We didn't sort it that way. We just opened them, and if they were pink-yellow or yellow-pink, we just put them in a stack here. And then these were when they were double yellows. Again here, yellow-orange versus orange-yellow. We didn't really differentiate. And so you can see our results here. I'm not sure if this is all of them. We may have eaten a few before it got to the picture, but I'd like you to notice something. It's kind of interesting here. At least it's not consistent, but you see the doubles tended to happen less often as, when I say double, like yellow-yellow, versus a pink-yellow, yellow-pink. This happened twice as often as the yellows. And a yellow-orange versus an orange-yellow happened twice as often as double yellow. And maybe not quite as much, but compared to double orange. Now, we have an exception here. We've got these orange reds happen about the same amount as just the reds, just the yellows, just the pinks, or just the oranges. And then here we've got pink reds happening a little bit less often, but pink oranges about twice as much. Okay? And there's two ways to solve this problem. One is to think of each starburst as an independent event. I think of the first starburst color and then the second starburst color. The second is to think of these as a pack of starburst. And so you get one pack, and it's either a pink-orange or orange-pink. It doesn't matter. The order doesn't matter. We treat them the same. And in the next video, I'll really dive into each of those two approaches. So here's another chance for you to pause the video and think about it on your own.